Iris dataset is a classic benchmark dataset in machine learning, often used for classification tasks. It consists of measurements for 150 iris flowers across 3 species: Iris setosa, Iris versicolor, and Iris virginica. Here's how we can define the iris data in matrix form using matrix notation. Data matrix. X. Dimensions. nxm, where n equals 150, number of data points, and m equals 4, number of features. Columns. Each column represents a feature. Column 1, sepal length, cm. Column 2, sepal width, cm. Column 3, petal length, cm. Column 4, petal width, cm. Example: sepal length, sepal width, petal length, petal width. Class 5.1, 3.5, 1.4, 0.2, Iris setosa. 4.9, 3.0, 1.4, 0.2, Iris setosa. 4.5, 2.3, 1.3, 0.3, Iris setosa. 147 more rows. 6.9, 3.1, 5.1, 1.5, Iris virginica. 5.9, 3.2, 4.8, 1.8, Iris virginica. 6.7, 3.3, 5.7, 2.1, Iris virginica. Target vector, y. Dimensions, nx1. Values. Each element represents the species of the corresponding data point in the data matrix. 1. Iris setosa. 2. Iris versicolor. 3. Iris virginica. Example: class 1, 1, 1, 147 more rows. 3, 3, 3. Using matrix notation, we can perform various operations on the iris data for machine learning tasks, such as calculating mean and standard deviation for each feature, mean, x, std, x. Computing pairwise distances between data points, x at xt. Visualizing data distribution, plotting features against each other. Training machine learning models, feeding x and y to algorithms like support vector machines or k-nearest neighbors. By understanding the iris data in matrix form, you're equipped to tackle various machine learning problems and extract valuable insights from this benchmark dataset. I hope this explanation clarifies the representation of the iris data in matrix form and highlights its usefulness in machine learning tasks. Feel free to ask if you have any further questions.